Again, the median of a triangle connects one vertex to the midpoint of the opposite side. There's 3 medians in a triangle. I could choose, give me a vertex besides vertex A. C? If I start at vertex C, then I'm going to find the midpoint of side AB, which right now I'm approximating. But I know it's a midpoint because look, it's marked. And I connect those with my straight edge, my magic straight edge that's in my head right now, and that is a median. There you go. So there's more than one median. You know what's really cool? If I do a third one, just, you know, fun. If I do a third one, if I connect B to the midpoint of the other side, do you think it's coincidence that they all met in the middle, in the same point? You think that's coincidence? It's not. That will happen. All right, so using the blue one, the original one that was drawn there, blank is the midpoint of blank. What is the midpoint with the original one that was drawn here? What's the midpoint? This one here. What was the midpoint? D. Point D is the midpoint of what? What's D the midpoint of? BC. Segment BC. And then what is our median, which I circled? Our median is AD. Next vocabulary word is centroid. Centroid is the point at which all 3 medians of a triangle meet. So in this picture, the centroid is the point where all 3 medians meet. Blank is the centroid. In this picture, what's the centroid? Point G. Good. The centroid theorem. This might be the hardest thing about this. The centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. A little bit confusing. When we look at this picture here, if I've got B to F, this is a median. My centroid is at P. This is saying that to the vertex, it would be 2/3, and then that means that from P to F, the other side would be 1/3 of the original median itself. So this is always true that when you find the centroid, it's going to break it down into 2 pieces. One side that goes to the vertex will be the bigger one, and it'll be 2/3 the length of the original median. Okay, so let's fill this out. The medians meet at what in this picture? The medians meet at what? Okay. Point P, and what's that vocabulary word that is point P? Centroid, yep. P, which is the centroid. So here I'm going to fill out that BP, and I did not put a segment about it because I'm talking about distance right now. BP, do you see where BP is? That is 2/3 of the length of BF. So if I look at the whole median, the longer part is 2/3 the length of the whole median. So using that, if I'm looking at AE, I'm looking at segment AE, that median. Which segment is the 2/3? Cameron? Perfect. AP. And then if I'm looking at CD, Ryan, which segment is the 2/3 if I'm looking at CD? CP. You see how the first letter was always the vertex, and then the second letter was the centroid. So in this example right here, we have that Q is the centroid, and from S to Q is 8. We have to find Q to W and S to W. So S to Q should be 2/3 the distance from S to W. That's what the centroid theorem tells us. What do I know numbers-wise? What do I know distance-wise? What can I fill in? Lynn? SQ is 8. And I need to get SW, so I need to solve this equation by getting rid of 2/3. 2/3 is being multiplied. How do we cancel out 2/3 that's being multiplied? Alex? Did you say?
No, not what I meant. Multiply 3 over 2 on both sides.
Okay. So instead of dividing both sides by 2/3, because that's too hard, we're going to multiply both sides by its reciprocal, right? That's what you're saying to me? Okay. So we're multiply both sides by 3 over 2. Remember, when you multiply fractions, you're going to put that whole number over 1, and you go straight across. So I'm going to get 24 over 2 equals SW, and 24 over 2 is what? 12. So SW equals 12. That's one of the answers we had to find. So if the whole thing is 12, then what's QW? 4. That was a ding! You got it right. Questions on that? So we're just using the formula that they gave us, solving for the missing piece, and then do you know how we got 4? If you didn't get 4, do we know how we got 4? Maggie? I did not, because if I did 12 times 2/3, that's going to be 8. I did. That's what we did. Yeah, when we looked over here, since the whole thing has to be 12, 8 plus what is going to make that 12, 4. Okay? So it says you try. Point Q is the centroid, and VQ is 5. Find RQ and RV. I'm going to stop talking for 30 seconds while you try, and then we'll do it together. Good at fractions. You don't even have to do all this equation stuff. You're good at fractions. All right. So what I did first, I know not everybody got done, but some of you might be on the wrong track, and I want to get you before you go all the way through. You should not have horrible numbers on this. So if you're getting horrible numbers, you're doing something wrong. So for this one, the first thing I noticed was that with Q being the centroid, R to Q is that part that is 2/3 the length of RV. So this is what I set up first. And then I looked over and I don't know either of these amounts. So I can't solve using this. But I did, when I was talking about 2/3 up here, I did tell you if this is 2/3, then this side is what? 1/3 to make 3 full thirds. So this 5 here is 1/3 of RV. So 5 is 1/3. That means that there's like 3/3 here. How long is the whole thing going to be? If this is 1 of those thirds, then we've got 2 of those thirds and the 3 of the thirds. This whole thing's going to be 15. Or I can just solve my equation right here, multiply both sides by 3, and I get RV is 15 total. And if RV is 15, and I know that QV is 5, and I subtract them, then my missing piece, RQ, is going to be 10. Because we're dividing this into thirds. 2 of the thirds is the longer one. The other third is the shorter one. So thirds. Like pieces of a pie, only in a line. Oh, do you miss doing fractions back in the day? No, not at all. All right, so that's centroid, that's medians. Next is altitude. Altitude is the perpendicular segment. It is not necessarily a bisector. It is a perpendicular segment that starts at a vertex and makes 90 degrees with the opposite sides. So in this picture, if Q is the vertex, I'm going to connect it to PR and it has to make 90 degrees. This picture is a little bit different, and usually it's it looks like this, so it's a little bit easier to see. In this picture, QPR is the triangle. What kind of triangle is this? What kind of triangle is this? Oh no, we've forgotten everything we learned. Jesse, what kind of triangle? Obtuse triangle, thank you. Obtuse triangle. In the obtuse triangle, there is a situation where when we drop down 90 degrees to the base, it's not inside of the triangle. It's actually outside of the triangle. Because you have to make 90 degrees with the base no matter where that is. So we have to kind of like pretend to extend that out. So the altitude is the height from top to bottom. Excuse me. So it can be inside or outside of the triangle. The orthocenter would be if we drew all 3 altitudes. We used all 3 vertices. We drew all 3 altitudes. Where those 3 altitudes meet is called the orthocenter. The orthocenter can be inside or outside of the triangle. So example 2, we've got point A, it says to use point A, and just approximately draw the altitude. So we need to make sure that whatever we draw connects to the opposite side and makes 90 degrees. So do your best to make it look like a 90-degree angle. Then part B says, now let's use point D. If we're talking about how tall this triangle is, then I'm going straight down to the base. It's going to go straight down, and that's not going to be inside of the triangle. Bless you. So I have to extend out this base to show where the altitude would be. And then there's you try. So once you have mine copied, go ahead and you try to draw the altitude. Make sure you notice what point it's telling you to do. I wonder how this works. Can you guys actually turn your Chromebook like I can turn my paper? No, like the whole Chromebook, not just on the screen. Like if you turn it, does your Chromebook like turn the screen? It does. So you can't like look at it sideways. I was just look at the point it's telling you to draw from. How are you doing this if you don't have a stylus? Borrowing the person's stylus next to you. How are you doing this without a stylus? Oh, hey guys. My bad. Totally forgot to tell you the notes changed since yesterday, so you did re-download. My bad. I should probably say that on the video too. So if you don't have that, go open up the notes that are on today. Steven, you know what I'm talking about? I'm so confused. You guys don't know? Why'd you say something sooner? I forgot.
It's all the same until now.
Yes, until now. You're right. Cause I'm sorry. So yesterday, me and the other teachers, we just tweaked the notes a little bit. So, and I forgot to tell you guys when you came in, not a big deal, because you know what? It's not like we're wasting any paper. You could just save what you have so far and then start at the new part. So you need to go back to Canvas, which I'm sure is already open, right? No? It'll take a moment to open. All right, so and then go to today and download the day 2 notes. So day 3 notes might be tweaked as well. I apologize because I shouldn't have uploaded all 3 of them together. No harm. So if you don't have the right ones, go back to Canvas, download today's notes, not yesterday's. Excuse me. And then go find where we were in the notes. And then if you don't have a stylus, how are you drawing on it?
You can use your mouse.
Oh, okay. Use your mouse. I was going to say you could also maybe borrow somebody's stylus for a half a second. Nearby there's somebody that has one. Do you have the correct one? You have the correct one? You have the right one? You have the right one? Okay, so we're going from point A to the other side. Okay, you're going to make 90 degrees side C. That looks good. Right? You are, but does that look like it's 90 degrees? No. Well, just, like, it just takes some practice. Like, to me, if I put a corner in there, it's definitely smaller on that side and bigger on that side. So I feel like it needs to go more this way. So that one looks pretty good. Okay, so this one, well, first of all, this one, D, needs to connect to FE. And this is where the 90 degrees should be on FE. You were doing E for this one. And then this one, A, has to connect to E. Yeah, exactly where your hand was just a second ago. It's going to go like that. Yep. Okay, so I'm going to go ahead and fill out the A and B that you try. A few of you have it wrong. So point A has to connect to the side CB, and it has to make 90 degrees. So if it is outside of the triangle, it's still going to be on the line CB. So I have to imagine point A making 90 degrees with CB. Okay. And I think part of that might make it a little bit more challenging is, for me, I can really do it well if it is facing this way, where the base is kind of the way I'm normally used to seeing bases. That's why I was asking if you could turn it. But if you can't turn it, I could understand where that might get a little confusing. And then this one, point D, that has to connect to FE. It has to make 90 degrees. So I'm going to go straight to FE and make 90 degrees. So that's where that one should be. And again, if I turned it, then it would look more like a height at that point. Okay? Does anybody need to see this longer? Could I go to my next page? All right. Last stuff. Mid-segment. Oh my gosh, we gotta hurry. Mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. So, side MN, MP, and PN, these are each mid-segments because they connect the midpoints of two opposite sides. See how M to P connects midpoints to the two opposite sides. And if we connect all three of them, they make a triangle. They form a mid-segment triangle. Triangle mid-segment theorem. The segment connecting the midpoints of two sides of a triangle is parallel to the third side. So if I connect midpoint D and midpoint E, it will be parallel to this third side that didn't have the midpoints on it. This is always true. And what also is always true is it is half as long as that side as well. So this one is half the length of this one every time. So in this picture, DE is the mid-segment, and DE is parallel to AC, and DE equals half of AC. Notice when I talk about the figure, I have the segment above it. When I talk about the length, I don't have the segment written above it. Find each indicated length. So for this one, we're finding CD. If XZ is 16, how long is CD? Help me out. 8. Excellent. Half the length of 16. For this one here, x plus 9 and 2x plus 3. So 2x plus 3 is the mid-segment. That one's going to be half of x plus 9. You see how I set up an equation by saying it out loud? 2x minus 3 is half x plus 9. And I'm going to solve this equation. 2x minus 3 equals 1/2 x plus 9/2. Oh, I hate fractions. You guys hate fractions? Anybody? Oh, I forgot. You guys love them, except for Raylan. Raylan loves them. I mean, hates them. But everybody else loves them. If you don't really like fractions, you can multiply everything by 2/1 or whatever the denominator is. If you double everything in this case, if I double a half, I get 1. If I doubled 9/2, I get 9. Just got rid of fractions. Or you can just deal with fractions. It's up to you. I'm going to subtract x. I'm going to add 6. Divide by 3. You get x equals 5. Is that what I needed to find? Nope, I need to find yw. Okay, so 5 plus 9? 14. So what's 2x minus 3 without plugging it in? 7. Okay. And then the other 2 are you tries. I'm going to not do those because of time. I'm going to pass out your worksheet. You got a worksheet for your assignment today. All right. Same thing. We're going to grade it in class tomorrow.